Hey, it's Kai. Today we're talking about constraints in SQL, which are just rules you attach to your table columns. Think of them like bouncers at a club door. They check every row before it gets in and turn away anything that breaks the rules. We'll cover the four you actually use every day, and by the end you'll know exactly when to reach for each one. So first, plain words. A constraint is a promise your table makes about its own data, like saying every user must have an email. The magic is the database enforces it for you automatically. You might wonder why that matters, and here's the thing. If the rule lives in the database, no forgetful app code can ever sneak bad data past it. In short, a constraint is a rule the database refuses to break. Imagine a form where the name field is marked with a red star. You literally cannot submit it empty. That's not null. It just says this column must always have something in it. Notice what happens when we try to insert a row with no name. The database slams the door and rejects it. In short, not null means this field can never be left blank. Unique UE is like assigned seats at a theater. Once someone's in seat 4B, nobody else can claim it. It stops two rows from sharing the same value in that column. See how the second insert with the same email gets rejected? That's exactly the point. One quick heads up though. Unique usually still lets multiple empty values through, so pair it with not null when you need both. A primary key is like an employee ID badge. Every person gets exactly one, and no two people share a number. Here's the trick. A primary key is really just unique and not null glued together, so every row is guaranteed to have its own identity. You get one primary key per table, and it's how the database tells your rows apart. In short, the primary key is the row's permanent, one-of-a-kind name tag. Now the fun one. A foreign key is like writing a friend's phone number in your contacts. It only makes sense if that person actually exists. Here, every order's user id must point to a real user's ID. So if you try to create an order for user 99 when there is no user 99, the database says nope. That's how tables hold hands and stay honest with each other. Let me show you the shape of it. The orders table has a foreign key pointing back at the users table's primary key. Follow the arrow, orders depends on users, never the other way around. One user can have many orders, but every single order has to trace back to exactly one real user. That arrow is the whole relationship in one picture. Here's a classic trap I've fallen into. Early on I tried to delete a user who still had orders attached, and I got a wall of errors I didn't understand. Turns out the foreign key was protecting me. Those orders would have become orphans pointing at a user who no longer existed. You either delete the orders first or set up on-delete cascade to clean them up automatically. In short, you can't delete a parent while its children still cling to it. A few more banana peels to watch for. People assume unique blocks empty values, but it often lets several through, so required fields still need not null. Another one is trying to add a constraint after the table is already full of messy data. The database will refuse if the existing rows break the new rule. This is my honest take. Constraints feel like annoying paperwork on day one, but they are wildly underrated. They catch bugs at 3 in the morning that your app code never let. So why not just validate everything in your application code instead? You can, and it's nice for friendly error messages. But here's the difference. App checks only run if your code remembers to run them, and a second script or a manual query can waltz right past them. Database constraints are the last line of defense that nothing gets around. Plus points for app checks, better user messages. Minus, they're skippable. Constraints, the reverse. Let's line them all up. Not null means no blanks. Unique means no duplicates. Primary key is those two combined to name each row. And foreign key ties one table to another. And notice you can stack them, like making email both not unnull and unique on the same column. Pick the rules that match what your data actually promises. Clean. Alright, quick recap. Constraints are rules. The database enforces so bad data never even makes it in. Not null, unique, primary key and foreign key each guard a different promise, and you should bake them into your schema during design, not bolt them on after the mess. Let the database carry this weight for you. That's what it's best at. That's the hard part explained. Here's the easy part. Hit follow.